Next important one is Vernier scale. Can anyone tell me what is the least count of Vernier scale? Least count of Vernier scale. Anyone know what is the least count of Vernier scale? Least count of Vernier scale or screw gauge or micrometer, which you learn in your physics classes.
0.01.
0.01. So you can measure up to 2 units or 3 units in the Vernier scale. 0.01. You can measure 2 units or 3 units in the Vernier scale. You can measure 2 units or 3 units. Suppose there's a value of 4.56 meters. So least you can measure up to 0.01 meters. So it is a least count. So we can measure up to 3 units. The Vernier scale, we can measure up to 3 units. Okay. The smallest distance can also be measured by the Vernier scale. If you want to calculate the least count, main scale division minus Vernier scale division, which make you can get the least count of the Vernier scale. So one least count equal to one main scale division minus one Vernier scale division. So Vernier scales are classified into two types. One is direct Vernier or forward or backward. Okay, there are two types of Vernier scales. One is forward or backward. Okay. So what is meant by forward? What is meant by backward? So what is meant by forward? What is meant by backward? Suppose if you take, this is my zero division. Suppose I take, this is my scale, and this is my zeroth line. This is my zeroth line. So in this scale, which one is backward? Which one is forward? Which will draw a line. This is my zeroth line. This one I call it as backward. This one I call it as forward. So from this scale, if I move to my left, this is my backward. I'm going backward. If I'm going forward, this is my forward scale. Okay. There are two types of Vernier. One is backward scale Vernier and forward Vernier. In the problem, they can ask solve a problem by backward scale. In the problem, they'll ask solve a problem Vernier scale problem by forward scale. So depending upon the situation, you have to use either backward scale or forward scale. So we will be learning what is meant by forward and what is meant by backward. Okay. So this is your scale. This is your scale, and this is your 10 divisions. First division we'll mark it as 0, and we are dividing this 0 to A line into 10 equal divisions. Okay. So similarly, this is the 9th point, 8th point, 7th point, 6th point. Okay. So in the forward Vernier, what we do is, this is my 10th point, this is my 9th point. So what I will add one more scale called Vernier scale from 9th to 0. I will add Vernier scale from 9th to 0. That is called my backward scale. So total how many divisions? Here we have only 9 divisions. Okay. If we are making 9 divisions, it is called forward scale. Okay. And similarly, if you go the backward scale, if you are using the backward scale, so this is my normal scale, and again I have made it as plane scale. In the plane scale, this is my main divisions, this is my sub of divisions. So what I do is, I will take one more unit. I'll divide this as 10th, 0, A to 0, made 10th division. So whatever maybe the 9th to 10th division is there, same division, I'm adding one more scale here. Okay, I'm increasing one more scale, and I'm making it as 11 divisions. If I make 11 divisions, it is called backward scale, because this is your normal scale. From normal scale, I'll add 1 point. After 10 divisions, I'll make one more divisions. I'll make it as 11 divisions. It is called backward. From the 10 divisions, if I make one forward and I'll take only 9 divisions, then it is called as forward Vernier or direct Vernier, we call it as. Okay. So I'll explain once again so that you will be understanding why we are taking 9 and 10. Okay. Vernier scale has been created by Paul Vernier. He was an engineer and mathematician. So as a mathematician, he has seen the tables, different tables from 1 to 15. He has seen the different tables and he has observed one thing. Suppose if I want to make any 3 units, so what there are total 3 units, such as if I want to make any three division scales, such as main unit, subunit, and subunit. So I suppose I'm taking this is my value 4.56. So he has observed the last digit. The last digit should contain all the letters from 1 to 10. All the letters from 1 to 10. He has seen this one, and he has seen few tables where the last digit of the table is 1 to 10. Can anyone tell me what is the last digit? Suppose there are two digits number, 1th digit and 10th digit. On the 1th digit, all the digits should start from 1 to 10. What are the tables between 1 to 15? 1 to 15 table. In the single digit, it should be from 1 to 10. Any table? Already one you have, but one is only, it doesn't have the second unit. 10th division it doesn't have. 1th and 10th division. So on the table from 1 to 15, what are the tables where you can find the single digits 1 to 10 directly? Any table you can find? Yeah, anyone respond? 1 to 15 table, on the one side of the division, one side, it should be sequence of the digits 0 to 1, 0 to 10, or some 10 to 1, reverse or forward. Any divisions? Understand my question? Suppose it is example 71 is there. So you have to say a table such a way that after this one example 82 and 93, like that. If you see this side, it should be as a repetitive between 1 to 10 or 0 to 9. It should be like this. Any table where you can find this kind. So what the Vernier scale, Paul Vernier has done is he has performed, he has seen all the tables, and he has made sure that when he sees the ninth table, it comes as 9, 18, 27, 36, and so on till 90. Okay. So 9 ones are 9, 9 twos are 18. So like that, he has seen this digit has in reverse one 0 to 9 to 0. And he has performed -1 to the 10. And he has done +1 to the 10. It has become 11. So here what he has done is he's seen the last two digits. Last digits are like 11, 22, 33. So these last digits are in 1 to 10. So what he has, by looking at this table, he has created the Vernier scale. Okay. So in the Vernier scale, what we do is this 9 divisions, we make it as it is taken as the 9th table, and when you take the 11 divisions, it is taken as the 11th table. Okay, so you have to take it in the if you are using the backward Vernier, you have to use 11th table. If you are using forward Vernier, you have to use the 9th table. You have to use. Okay. So Vernier scale has total these scales. One is primary scale and Vernier scale. Primary plane scale. So you have to construct a plane scale. On the plane scale, you have to create a Vernier scale. On the plane scale, you have to create a Vernier scale. So what are the Vernier scale? The Vernier scale is derived from the plane scale, primary scale. From the primary scale only, you have to divide Vernier scale. Suppose the primary scale is in metric units, so Vernier scale will be in metric units. Suppose the primary scale is in imperial units, feet and inches. So you have to create Vernier scale with respect to the primary scale. Okay. So this is a problem. In the problem, this is my division. I have divided this into, this is my subdivision. This is my subdivision. This subdivision I divide into 10 equal parts. Then what I have to do is, I'm explaining the backward Vernier. So listen. So whenever I'm taking principle of Vernier, I'm explaining. AO represents 10 centimeters. Example, AO represents 10 centimeters. And we are dividing this AO into 10 equal parts. Each represents 1 centimeter. Okay. Then what we have to do is, we have to take what is the distance between this is my B example. So this is equal, whatever may be the 1 centimeter distance. That 1 centimeter I have to add one more here. So I'm adding one more here. What are the measure? I'll measure 9 to A. 9 to A is the 1 centimeter. This measure, I'll add one more thing here. What are the I will take one division, one subdivision, and I'll add one more subdivision here. That same division length I'm adding here. Then what I do is, this total distance between, already this is 10 centimeter. I'm adding one more centimeter. Total become 110 centimeter. Total become 110 centimeter. Then what I have to do is, this 110 centimeter I have to divide into 10 equal parts. This 110 centimeter I have to divide into 10 equal parts. Each part will become as 1.1 centimeter. Each point will become as 1.1 centimeter or 11 mm. 1.1 centimeter equal to 11 mm. Okay. So I'm explaining once again. So this is your plane scale. On the plane scale, this is my 10 centimeter line. And this 10 centimeter line are divided into 10 equal parts. What are the one part? I will add one more part here. From this one, I'll add one more part. I'll measure this distance. I'll transfer the same distance. So this distance is 10 centimeter. This distance is 10 centimeter. And this distance is 11 centimeter. And now I'm dividing the 11 centimeter into 10 equal parts. So each part will become as 1.1 centimeter. 1.1 centimeter or 11 centimeter. It will become as 11 mm. 1.1 centimeter or 11 mm it will become. Okay. So each part will become 11 mm, such as 0, 11, 22, 33, 44, 55, 66, 77, 88, 99, 0. It will become like this. Okay. So each will become, if I want to subtract this and this is my 10 mm. 10 mm. 10 mm by this one, if I make, it will become 11 minus 10, it will become as 1 mm. If I want to measure, this is my 7th point. So 70. 77 by 70, it will become as 7. Okay. So similarly, if you are dividing 22 minus 2, it will become as 0.2 centimeter. Okay. So this is the principle we use in the Vernier scale. Okay. So I will start the construction of Vernier. So example, what the Paul Vernier has done is, he has created this one. Suppose if I want to measure 4.56, example, if I want to measure 4.56 meters by using the backward or by using 11th table, how I can divide? Can one tell me? Generally, in the plane scale or in diagonal scale, what we do is, we measure this as 4 meters plus 5 decimeters plus 6 meters. 6 centimeters we measure generally. But if I want to measure in terms of backward, in terms of Vernier, what I have to do is, I have to take the 6. I have to take this 6. This 6, where it will come in the 11th table. In the 11th table, where it will come, this one, can anyone tell me? This 6, see only the last digit. Last digit. Tell me where the letter number 6 comes in the 11th table as a 1th digit. Yeah, you have to respond. Where this number 6 digit 6 comes in the 11th table as a single digit. Okay, so it will comes at the 66. In the 66, this 1th digit is 6. So what this Paul Vernier has done is he has performed, this is 4.56 and this is 0.066. So what he has done is minus 0.66. This is 0.66 meters. It is 66 centimeters. 66 centimeters equals 0.66 meters. So what he has done is 6 minus 6, it is 0. Then 4.5, 15 minus 6. 15 minus 6, 9 and 3. So from the main scale, you have to take 3.9 meters, and from the Vernier scale, you have to take 66 times. Okay, so what he has done is, so if you see 4.56, if you see 4.56 meters, how it is divided is 3.9 meters, 3.9 meters plus 0.66 meters. Then you can generate the divisions in the Vernier scale. That is what Paul Vernier has done. Okay, I'll give you one more number. How is 123? 1.23 meters. How you will divide 1.23 meters in the Vernier scale? Can anyone tell me? Yeah, can anyone tell me how to divide 1.23 meters divisions in the Vernier scale? Okay, so this digit 3 comes in the 33. So when you are solving the Vernier scale, what you have to do is you have to minus 0.33. You have to perform minus 0.33. Will become as 3 minus 3 0. Yeah, so 0.9. So how you have to make a division is 0.9 meters, 0.9 meters plus 0.33 meters. If you add these both the things, then you'll get the Vernier scale. On the Vernier scale, you have to measure 0.33 meters. On the main scale division, you have to measure 0.9 meters. So similarly, one more problem, 1.43 meters. Can you tell me what is how to measure 1.43 meters in the Vernier scale?
1.1 plus 0.33.
1.1 meter plus 0.33 meters. So this is the 11th table, which is nothing but the backward Vernier. Similarly, if I want to perform the same problem in the forward Vernier, suppose there is a problem called 4.58 meters, and I have to measure this 4.58 meters into forward Vernier, 9th table. What is the value? How I can divide? 4.58, I have to use the 9th table and I have to solve the problem, which is called as the forward Vernier. So on the 9th table, where you get the digit 8 in the 1st place?
2 are 18.
Repeat once again.
9 2s are
9 2s are 18. So I have to separate how much value I have to subtract? It is 0.18. 0.18 I have to separate. So the value comes as 4.4. So by Vernier scale, if I'm solving by the forward Vernier scale, I have to make it as 4.4 meters plus 0.18 meters. from the Vernier scale, then I can get in the forward Vernier. Okay. So I'll give one more time, one more problem. Suppose I'm solving 1.67 meters. I need to have in the backward Vernier and forward Vernier. What will be the value? How to divide? This is my backward Vernier, this is my forward Vernier. How to divide 1.67 meters? Then everyone raise their hands. I'll be taking the attendance. Tell me the solution also. How to divide? What is the final value by using backward Vernier and forward Vernier? How to make the division? How to measure the distance to be measured? So coming to the backward Vernier,
1.4 plus 0.27.
1.4 plus 0. For the forward we use 9th table. Forward we use 9th table. Backward we use 11th table. Okay. So here it comes as 1.4 plus 2.7 meters. What about forward backward?
0.9 plus 0.77.
0.9.
Timing completed, sir.
0.9 plus
0.77.
0.77. Okay. So how we do is here we will be making minus 0.77. We have to subtract here, and we have to subtract 0.27. We have to subtract, and whatever the value we get, we have to add. Once watch this video, so you will be understanding. So in this scale, what we do is we add one more unit. We add one more subunit, and we take the vertical height as 5 mm, and that 10 equal parts. So this is my 10. I'm adding one more. So total will become 11 parts. This 11 parts I'm dividing into 10 equal parts. So once watch this video. So in this video, they are saying that RF is 1.25, RF is 1 is to 25, and maximum length is 4 and maximum length of the Vernier scale is 4 meters. From the 4 meters, you have to measure 2.39 meters and 0.91 meters. Okay. So can anyone tell me, if I use the for the 2.39, if I use the 11th table, what is the backward Vernier? What is the value? What is how I can divide this one? 2.39 meters.
1.40 plus 0.99.
1.40 plus 0.99. Okay. So 0.99, you have taken the forward Vernier. Okay, you have taken the backward Vernier. So I have to subtract 0.99. So from the Vernier scale, I have to highlight only 0.99. On the plane scale, I have to highlight 1.40. Similarly, 0.91 by using the forward Vernier, by using the backward Vernier.
Zero 0.11, 0.8.
0.8 meters plus 0.11 meters. Okay. So I'm using same 11th table. So I'm subtracting 0.11. So it will become 0.808 meters plus 1. Same thing he will use in this one. Okay. Watch the video.
division into again 10 equal parts, which represents 0.1, 0.2, 0.3, 0.4 up to 0.9 and 1 meters. Okay, and give the numbering as 0, 0.1, 0.2, 0.3 up to 1 meter. Now, for constructing the Vernier scale, take an additional dimensional division, one division, take the extra division to the left side of the Vernier scale. Here, first I am representing the units. Main units are in meters and sub-units are also in meters like 0.1, 0.2, 0.3. Next, we can also divide the remaining divisions also into 10 number of equal parts for representing the decimal values of the meters. That is 0.1, 0.2, 0.3 meters. Next, take an additional division to the left side of the Vernier scale rectangle and divide the total, the distance, that is 0 to an additional division up to 0 to additional division, and take another rectangle above that and divide it into 10 equal parts. So here each division represents 0.11 meters. How it could be means, here we have taken extra point as 1.1. By considering the length of 1.1, we have constructed a rectangle, small rectangle, that is Vernier scale, and we have divided it into 10 equal parts. That means 1.1 by 10 means 0.11. So here each division represents 0.11 meters. So give the numbering as 0.11, and this second division will be 0.22, 0.33, 0.44, 0.55, 0.66, 0.77, 0.88, 0.99, and last one will be the 1.1. Okay, so this is the Vernier scale we have constructed. By using this, we need to show 2.39 meters and 0.91 meters. So for that, first we consider 2.39. So here, for representing this 2.39 on this Vernier scale, first we need to subtract the 9 related value on Vernier scale. So here the 9 related division is 0.99. So for take this 0.99 and subtract from this value. So when we subtract 0.99 from 2.3, we get as 0.40, 1.4 we get. Okay, 2.39 minus 0.99 means we get 1.40. So here we have subtracted 0.99. So draw a line from 0.99. Draw a vertical line from 0.99, and the remaining value is 1.4. So 1.4 means here the value is 1.4, 1.1, 1.2, 1.3, and 1.4. And from the 1.4, draw a vertical line. Okay, so this much distance will be equal to 2.39. So then draw a vertical line, dimensional line, and represent 2.39. So once again, listen here. For representing this point 2.39, we have to first consider the division related to 0.09. So related to 0.09 is 0.99. So take this 0.99 and subtract from the dimensional value that we are going to represent. So 2.39 minus 0.99 means we get 1.4. So we have subtracted 0.99 and we have drawn a line, and the remaining distance is 1.4. So here from 1.4 we have drawn a vertical line. Then the distance between these two vertical lines will be the desired dimensional value, that is 2.39 meters. Okay, and similarly we need to represent 0.91. So for this also, first consider the division that is related to 0.01. So here 0.01 related division is 0.11. Take this 0.11 and subtract this distance from 0.91. Okay, so here we have subtracted, we can subtract the value 0.91, subtract the value 0.11 from 0.91. When we subtract that, we get 0.80. Okay, so first draw a line from 0.11, then draw another line from 0.80. So where is the 0.80? Now we have to represent 0.80. So the remaining distance is 0.80. Means here the first division is 0.1, 0.2, 0.3, 0.4, 0.6, 0.7 and 0.8. So this one is the 0.8. So when we draw a vertical line and represent the dimensional value, it can become 0.91. 0.80 plus 0.11, that is equal to 0.91. So draw a vertical line from 0.8. Okay, then draw the dimensional line in between these two vertical lines, then represent the dimensional value, that is an
So in this case, so from here you have to measure 99, 0.99 plus 1.4, total become 2.39, because we have to give from the 1.4 plus 0.99 will become 0.91.